Okay, now we're going to review something that we did last week, but it's been a while since we touched this. So for those of you that were absent on this day, I'm going to review what we were doing. For the rest of you who were here and kind of do understand the concept, you could go ahead and work on the worksheet silently while I go over this for the students who weren't here or for anyone who needs clarification on what we did last Wednesday. So what we're doing is, before we even start with the worksheet, I want to talk about the zero product property. Now in math, I know if I have two things being multiplied together, and if they equal 0, then I know either A or B is 0. Okay? It doesn't have to be both A or B. One of them just has to be 0 in order for that to be 0. Okay? So we're going to take this property and we're going to use it to solve quadratics. So remember, quadratics are our equations with a power of 2. So let me show you how the zero product property is used in quadratics. Well, remember from last chapter, we factored polynomials, specifically quadratics, and we got to factors. Now, remember, if I have something that looks like this, this means x plus 4 times x minus 3 is equal to 0. So this times this is equal to 0. So what that means is either this factor of x plus 4 or this factor of x minus 3 is equal to 0. Okay? So we have to, there's two solutions here. One when this factor will equal 0, and one when this factor will equal 0. So I'm going to split up my factors and make them equal to 0 to solve the equation. So I have x plus 4 is equal to 0, and then x minus 3 is equal to 0, so I just solved it using algebra. So x is equal to negative 4. I add 3 to both sides here, and x is equal to 3. So your answers here, you have two of them, are x is equal to negative 4, and x is equal to 3. Okay? So on the worksheet, number 1, number 2, and number 3 are kind of done the same way. So let me show you, for example, another one, just to have another example. If I have 4n times n minus 8 is equal to 0, there's a factor here and a factor here. So we just separate them into two equations. I have 4n is equal to 0, and then I have n minus 8 is equal to 0, right? Because it's 4n times n minus 8. So what I'm going to do is I'm going to divide both sides by 4 here, and this is obvious that n is equal to 0. Here I add 8 to both sides, and n is equal to 8. So once again, in this problem, either 4n or n minus 8 is equal to 0, so I solve both equations, and I get n is equal to 0, and n is equal to 8. Okay? So you could do 1, 2, and 3 on your own. What I'm going to do now is I'm going to do number 4. Okay? So you could follow along on your papers with number 4. I have p squared minus 6p is equal to negative 5. Now, I know this is quadratic in form because I have a square here. And now look, I have a b term, which means I have to use factoring to solve this quadratic equation. Last week, we, if it didn't have a b term, we used square roots to solve it. But if there's a b term, one of the ways we're going to solve this is to use factoring. Now, in order to use the zero product property, the quadratic needs to equal 0. So it's equal to negative 5. So what I need to do is I need to add 5 to both sides. And so now I have p squared minus 6p plus 5 is equal to 0. Now, what we need to do to get this into its factors is we are going to factor it. Now, we have to remember from last chapter, how do we factor a trinomial when there's when the leading coefficient is 1? Well, that's what we asked ourselves. Remember, we asked ourselves what multiplies to 5 but adds to negative 6. Since they multiply to a positive 5 but add to a negative 6, the numbers are going to be negative 5 and negative 1. Negative 5 times negative 1 is positive 5. Negative 5 plus negative 1 is negative 6. So the factors are p minus 5 times p minus 1. Okay? And then so we set this up as p minus 5 is equal to 0. P minus 1 is equal to 0. And then you just solve each equation. P is equal to 5, and P is equal to 1. Okay? So that should be number 4. Okay? So for all of these, now, that's number 4. I want to do number 6 with you also. Okay, so get that down. If you don't have it, you could pause the video if you need be. So, number 6, it's kind of the same thing. So I have x squared minus 6 is equal to negative x. We want this to equal 0, so I'm going to move the negative x to this side, plus x. Just remember, when you write this in order, when you write this as a quadratic, you want to write it in standard form, which means highest exponent to lowest exponent. So this will be x squared plus x minus 6 is equal to 0. If you write x squared minus 6 plus x, that will confuse most of you. So I want you to always write it in standard form, highest exponent, and then we go down in the exponents. So now we just ask ourselves, what multiplies to negative 6 but adds to 1? Positive 1. So I know one has to be positive, one has to be negative. The numbers are going to be 3 and 2. But since we want the middle term to be positive, our bigger number has to be positive. So it's x plus 3. X minus 2 is equal to 0. And then now we're going to use the zero product property to solve the equation. So I subtract 3 from both sides, and I have x is equal to negative 3. Add 2 on both sides for the second one, x is equal to 2. Okay? So that is how you solve number 6. Okay. Now let's go ahead and do 2 more together. Number 7 is the first one I want to do together. Number 7 is r squared plus r is equal to 0. Now it's already equal to 0, so we don't need to move anything to any of the other sides. But now look at this. This is not a trinomial. We have a binomial. So we can't use that what multiplies to, what adds to. But look at r squared and r. I could see that I could take out a greatest common factor between r squared and r. So my greatest common factor is r. And what I'm left with here is r plus 1. And remember, put the r on the outside. Okay? And then so now we have 2 factors. R is equal to 0, which is already solved. I have r plus 1 is equal to 0, so I subtract 1 from both sides. R is equal to negative 1. So my 2 answers here is r equals to 0, r is equal to negative 1. So how did I know to do this? Well, first of all, it wasn't a trinomial. And also, I just look at this, I see r squared and r, and I see they have something in common that I could take out. Okay. Now, the last one we're going to do is number 12. Okay. So, here's number 12. I have 7a squared is equal to negative 5 minus 12a. So what I'm going to do is I want everything to equal 0. I also want to keep the 7a squared positive. So what I'm going to do is I'm going to move everything to the left side. Okay. So what I'm going to do is I'm going to add 12a to both sides and add 5. Actually, I'll do it step by step. So I'm going to add 12a to both sides, and I get 7a squared plus 12a is equal to negative 5. It's still not equal to 0, so I'm going to add 5 to both sides. And so I get 7a squared plus 12a plus 5 is equal to 0. Although I think most of you can do that in one step, I did it in 2 steps just so you could see what I did there. In these problems, you always want the quadratic to equal 0. If it's not, you cannot use the factoring techniques that we learned. So we set this equal to 0. And now look, there is a coefficient in front of here, which means we have to use our box method. Okay? So over here, 7 times 5 is 35. And so what I'm going to do is I'm going to ask myself, so remember we have to put the first term here, last term here. What multiplies 35 but adds to 12? Well, that's really easy. That's 7 times 5. Okay. 7 times 5 is 35. 7 plus 5 is 12. And remember, we just put the a here. We put the a. And so now we're going to go ahead and factor out what we need to factor. So 7a squared, 7a. We factor out of 7a. 5a and 5. We factor out of 5. 7a squared and 5a. We factor out an a. And 7a and 5, we can only do a 1. So this factors into 7a plus 5, a plus 1. And now we just do our zero product property. We're going to do 7a plus 5 is equal to 0. A plus 1 is equal to 0. And now we just solve both of these for a, which you should be able to do on your own. So here on the left, a is equal to negative 5 over 7. And then here, a is equal to negative 1. Okay. So those are your solutions for the problem. And then so the rest on the back are the box method type of questions. Remember, how do you know the difference when to use the box method? If your leading coefficient is not 1, then we do this technique. Okay? So go ahead, work on this until I get back from the WASC meeting. And if you need any help, just ask your neighbor.